Okay, kids, so we're looking at variation, formulas, applications, and variation. And we'll be working with formulas, direct variation, inverse variation, joint variation, and combined variation. So I wanted to send you a video so you could finish the notes for this section, kind of get a good idea of where we're headed. It's not really that long, and I thought we would be able to finish it today, but I'm going to go over the first part for those who were absent. So we look at just some formulas, and formulas occur frequently as mathematical models. So you can kind of think that you had distance is equal to rate times time as one. You could have force is equal to mass times acceleration. You're used to those from science, right? Many formulas contain rational expressions. So we could actually take and we could say that R, the rate you go, is equal to D over T. So a rational expression. In the same way, we could take the acceleration and we could say is equal to the force over the mass. So we could write it and then we would have the equation solved for a specified letter. So we'll need to work with what we call rational equations. So we started out with a hydraulic system. A fluid is confined to two connecting chambers, and it makes it easier. And we were talking about what that would look like. And a perfect example of a hydraulic system would be like a jack, where you lift up your car. And it's a little easier, has a lever arm, and you're able to get the heavy car up pretty easily with a hydraulic jack. So we looked at the fact that if we want to solve for a sub 2, we would often cross multiply and get the expression you see that's circled and divide by f sub 1 to get a sub 2 by itself, and we would get this equation in the end. A sub 2 is equal to f2a2 over f1. So when you are programming, this is something where you often want to write an expression in terms of, you want to write an equation in terms of one specified variable. That variable then is going to have all the inputs that you see in the equation, and it'll pop out the quantity for the variable then. That will happen when you have all the inputs in place. So what I wanted to say is that sometimes we cross multiply in this part. We are multiplying by A1, A2 because we're employing the multiplication principle. This is the multiplication property for equations. I'll just put multiplication property of equations like that. That we can multiply on both sides of an equation, maintain the equality. So that's what we multiply by the LCD, A1, A2, and then we clear those fractions. Then you get what you see here in the numerator, and then you divide by F1, and you are able to solve for A2. And it's the same thing we got on the previous page. But you should understand that tricks like cross-multiplying are done with reasoning in the background, and it is just a trick for that specific case. Then we went on to talk about solving a rational equation for a specified variable, and these are the steps that you would use in order to solve for a specified variable. So I'll let you pause your video if you need to look at that. And then we talked about variation, and this is direct variation, inverse variation, and combined variation are the three forms that we're going to be discussing in here. So 1, 2, and oops, wrong place. 1, 2, and then 3. Okay, and so let's just get started with this. We had this perfect example at first, and I just left it up here as we talked about it. We're talking about a driver earning a certain amount per hour, and that's a rate, right? So you say to yourself, okay, that's a rate. In 1 hour, and $17 is earned, right, in total, and you would get that 17 times 1 hour. In 2 hours, then you see that $34 is earned. So you kind of get this picture of what's going to happen. In 3 hours, 51 is earned. So you see this list of ordered pairs. So it's really easy for us to understand how we would get an equation for that the amount you earn is $17 times T, the number of hours you work, right? We could also take that equation and we could do like that, where earning over time gives you $17. So $17 per hour. Well, earning over time has got to be the same. You're going to make 17 hours. So you could then set up, as I said down here, and I'll let you pause and read the entire page, but you could write E sub 1 over T sub 1 is equal to E sub 2 over T sub 2. And in this case, it will always equal, as I have up there, 17, okay? And as you see down here. So you have both forms of the equation that you can use. So that is a direct variation where you have this, where E is like the Y and T is like the X that you see there that wasn't there. When a situation is modeled by a linear function of the form Y is equal to KX or F of X is equal to KX, that's called a direct variation. And you often have these phrases, Y varies directly as X, then that's going to mean it's direct variation. Y is proportional to X, or there are a couple others, but those are the two main. K is called the variation constant or the constant of proportionality. So we would be able to write this equation, and we can also write it like this if we solve it for K, which is kind of handy sometimes. Okay, so finding the variation constant, if we have two forms of our equation that you see here, I want to just find the constant. So you could take the equation and you could substitute in the y and the x as I did here, and we got k is equal to 5. Or you could take the first kind. You could say 15 is equal to k times 3, and then you would still divide then by 3, and you would get k is equal to 5. You get the same thing, but you could use either form. When you have y and x, when you plug them in, you've already got k solved for it by itself. So that's kind of helpful too. Okay, to see what we mean, now here's the next kind, inverse variation. So that inverse means, like in the first example, when x goes up, y goes up, right? When x goes down, y goes down, so long as k is positive. Here, it's a little different. So it says that if 2 people do the job, it will take 4 hours, right? If 3 people do the job, it will take only 2 hours. So 3 people, 2 people, 4 hours. 3 people, it will take 2 hours, or 2 2/3 hours, sorry, 2 2/3 hour. So you see that the time is then going down. Here's the time on the side. So you have the number of persons and then the time, right? As you look at this. So when you have 4 people, it only takes you 2 hours to get the job done, which makes sense. So what's happening is as the number of people goes up, the time goes down. They are inversely related. So with an inverse proportion, okay, you can take the quantities, and we have PT is equal to 8, right? This product that's equal to 8. Note that the product of each pair of numbers is 8, right? If we say that, okay, 4 times 2, 3 times 8/3. So that's kind of interesting. Whenever a situation gives rise to pairs of numbers for which the product is constant, we say that they are inverse variations. So it kind of goes like this. PT is equal to 8. So that's the people times the time. The time in hours, remember, so since PT equals 8, the time T in hours required for the fields to be painted by P people is given by T is equal to 8 over P, which is showing that inverse variation. So I'm going to write it down here where we have T is equal to 8 over P. Okay, or using the function notation TP, T of P. Remember, we say that as T of P with the functional notation is 8 over P. So, important facts. When a situation gives rise to a rational function of the form f of x is equal to k over x, or y is equal to k over x, where k is a non-zero constant, we say that there is an inverse variation, okay? Y varies inversely as x, or y is inversely proportional to x, will lead you to that equation. The number k is called the variation constant, same as direct variation. We'll do one more problem with this then. So the time t required to empty a tank varies inversely as the rate of pumping. If a pump can empty a tank in 90 minutes at the rate of 1,080 kiloliters per minute, how long will it take the pump to empty the same tank? So we start off like this. We've got this equation, and all we need to do is put the information in. So we know that t is 90 minutes. We could put 90, I'm just going to remind you that it's minutes, is equal to k over, and the rate is 1,080. Now it's kiloliters per minute, right? So units are in agreement. So we have 90 then times 1,000. Got to make sure I have my calculator out here. 90 times 1,080 is, what do we get? We get 90 times 1,080 is, so I'm going to multiply those two. So I get 1,080 times 90 is equal to my k value. So k turns out to equal 97,200. Okay, so now I have the k value. So now I know my equation is t is equal to 97,200 over r. Okay, we'll finish this problem here. There's a mistake